Have you ever wondered about the mysteries of black holes? These celestial enigmas lurking in the farthest corners of our universe are some of the most intriguing objects in the cosmos. A black hole is an area in space where gravity pulls so much that not even light, the fastest thing known to us, can escape. This intense gravitational pull is what gives black holes their name. They're black because no light can get out, and they're holes because of the gaping void they create in the fabric of space. The concept of black holes may seem like a modern one, but it was actually first proposed way back in 1783. The brain behind this idea was John Michell, an English physicist. Michell proposed a thought-provoking theory. If a star had enough mass, it could generate a gravitational pull so strong it would draw in everything around it, including light, creating a dark hole in space. It's a concept that's hard to grasp, isn't it? An object so powerful, it can trap light. Something we see as untouchable and ever-present. But that's the marvel of black holes. They challenge our understanding of the universe and push the boundaries of what we think is possible. The idea of a star so massive and powerful that it could swallow light was met with skepticism in Michell's time. After all, it was a concept that seemed to defy the laws of physics as they were understood then. But Michell was undeterred. He believed in his theory, even if it was a little ahead of its time. And as it turns out, he was onto something. Black holes are now a cornerstone of astrophysics, a testament to the forward-thinking brilliance of John Michell. But acceptance didn't come easily. Michell's idea was revolutionary. And like most revolutionary ideas, it faced its share of resistance. It wasn't until nearly 140 years later that the scientific community began to accept the concept of black holes. And that acceptance came with the help of none other than Albert Einstein and his groundbreaking theory of general relativity. However, it took almost 140 years for Michell's concept to be widely accepted. Enter Albert Einstein and his theory of general relativity in 1915. This unassuming physicist with his wild hair and expressive eyes turned the world of physics upside down with his revolutionary theory. The theory of general relativity was more than just an explanation of gravity. It was a new way to view the universe. In essence, Einstein's theory proposed that gravity isn't a force that pulls things together, as Sir Isaac Newton had suggested. Instead, Einstein presented a radical idea that gravity is the result of the curvature of space-time caused by mass and energy. Think of space-time as a stretchy fabric. When a heavy object is placed on this fabric, it causes a dip or a curve. This is what we perceive as gravity. Now imagine a really heavy object so massive that it causes a deep, steep curve in space-time. So steep that nothing, not even light, can climb back out. This is the basic idea behind a black hole. A black hole is an area in space where the space-time curve is so extreme that it forms a hole, trapping everything that falls into it, including light. Einstein's theory of general relativity didn't just provide a mathematical description of black holes, it also offered a new perspective on their existence. Until Einstein, black holes were merely a theoretical curiosity. But with his mathematical framework, black holes became a physical reality. Einstein's equations predicted that when a massive star dies, it collapses under its own gravity, creating a singularity, a point in spacetime where the curvature becomes infinite. Surrounding this singularity is the event horizon, a boundary beyond which nothing can escape, marking the birth of a black hole. Einstein's theory of general relativity was groundbreaking, challenging, and it fundamentally altered our understanding of the universe. It paved the way for the discovery of black holes and their fascinating properties. It was Einstein's theory that finally gave black holes their due recognition. Fast forward to the 1960s and a new discovery about the birth of black holes. In the heart of this exciting era, American astronomers Robert Oppenheimer and Harvey Snyder made a fascinating revelation. They proposed that black holes, these enigmatic entities, could be born from the death of massive stars. Quite a dramatic twist, don't you think? So let's dive into this process. Stars, in their prime, are powered by the process of fusion. This is where hydrogen atoms are fused together to create helium, releasing a tremendous amount of energy in the process. This energy is what counters the inward pull of gravity, maintaining the star's structure. However, like all good things, this energy production can't last forever. As a star exhausts its hydrogen fuel over billions of years, it starts fusing heavier elements. This leads to the creation of a core packed with iron, a point of no return. Iron fusion doesn't generate energy, and without this outward pressure to counterbalance gravity, the core collapses. This collapse triggers an incredible supernova explosion, outshining entire galaxies for a brief moment. But what's left behind? A dense core, so dense in fact that it warped space-time around it, creating what we now know as a black hole. But not all stars end this way. Only those with a mass about 25 times that of our Sun meet such a dramatic fate. The others, like our Sun, will end their lives as white dwarfs or neutron stars. Oppenheimer and Snyder's work was a significant step forward in our understanding of these celestial phenomena. It provided a theoretical framework to understand how these gravitational monsters come into existence. However, it wasn't the end of the journey. This was a breakthrough, but there was still more to come. The year is 1971 and we have our first observational evidence of a black hole. Picture this. American astronomers Martin Rees and Sir Frank Rosen, armed with their tool of the trade, a radio telescope. Their target? A celestial object known as Cygnus X1. Now Cygnus X1 isn't just another star in the sky. As Rees and Rosen would discover, it's a supermassive black hole. This wasn't just an assumption or a theory, but it was about to be proven with some of the first observational evidence of its kind. In their pursuit of understanding the universe, Rees and Rosen were like detectives, following the clues that the cosmos provided. They focused their radio telescope on Cygnus X1, observing the radiation it emitted. What they found was extraordinary. The patterns of radiation from Cygnus X1 were consistent with the behavior expected of a black hole. This was monumental. For nearly 2 centuries, black holes had been a theoretical concept, something that existed in the equations of physicists. But here, for the first time, was tangible evidence. Evidence that could be measured, charted, and analyzed. Rees and Rosen's observations were a turning point. Their work provided some of the first pieces of evidence to confirm the existence of black holes. The theoretical had become the observable. The abstract had become the real. Of course, their discovery wasn't immediately accepted. There was skepticism, there were questions, that's how science works. But as more observations were made, as more evidence was gathered, the scientific community came to accept the reality of black holes. Rees and Rosen's work was a game changer. It was the spark that ignited a new era of black hole research. Astronomers worldwide could now look up at the night sky with a new understanding, a new perspective. Their discovery was a testament to the power of observation, to the power of curiosity. It underscored the importance of not just theorizing, but also observing, testing, and verifying. And so, in 1971, armed with their radio telescope and an insatiable curiosity, Rees and Rosen changed the way we see the universe. This discovery opened the floodgates to further exploration and observations. It was a giant leap in our understanding of the universe, a leap that continues to inspire astronomers to this day. The study of black holes didn't stop there. Indeed, since the groundbreaking observation of Cygnus X1 in 1971, our understanding of these celestial enigmas has deepened considerably. We've not only discovered more black holes, but we've also observed various types, including supermassive black holes, intermediate mass black holes, and small black holes. Each one presents a unique set of characteristics and mysteries, adding more pieces to the cosmic puzzle. The late 20th century saw the advent of more advanced technology, opening up new frontiers in black hole research. In 1995, the Hubble Space Telescope captured the first direct image of a black hole. Situated at the center of our own Milky Way galaxy, this black hole, known as Sagittarius A*, was finally revealed to us, turning theory into tangible reality. Fast forward to 2019 when the Event Horizon Telescope collaboration gifted us with another first. An image of the supermassive black hole at the heart of the M87 galaxy. This image, a glowing orange ring against the backdrop of infinite space, offered a remarkable glimpse into the universe's most secretive objects, further validating Einstein's theory of general relativity. But even with these leaps in discovery and understanding, black holes remain largely enigmatic. Their nature invites countless questions that continue to perplex scientists. How do they evolve? What happens within their event horizons? Could they be gateways to other universes, as some theories suggest? These are just a few of the mysteries that researchers around the globe are tirelessly working to unravel. Current studies are focusing on the effects of black holes on their surrounding environment, including their impact on galaxy formation. Cutting-edge technology, like gravitational wave detectors, are giving us new ways to observe and understand these celestial phenomena. Black holes remain a mystery, but they are one of the most fascinating objects in the universe. As we continue to learn more about them, we are sure to discover even more amazing things about these strange and powerful objects.